Today, we're going to pull back the curtain on a massive, hidden problem, one that costs our biggest industries billions of dollars in wasted energy and lost production. It's a story about a dirty little secret, an unsung hero, and a pretty brilliant, clean solution.
I mean, think about it for a second. The gasoline in your car, the electricity lighting up your room right now, almost everything we depend on comes from these incredibly hot industrial processes. So what's stopping all these massive systems from, literally melting down? Well, the answer is surprisingly simple, but it's also profoundly important.
And that answer is the heat exchanger. This is the true unsung hero of our modern world. Its entire job is to move heat from where it's not wanted to where it can be used or just safely removed. Honestly, you can think of it as the radiator for our entire industrial civilization.
And just like a heart, these devices are absolutely central to the health of the whole system. They are literally everywhere, working silently, completely in the background.
We're talking about the huge workhorses you'd find inside oil refineries, power stations, and chemical plants. There are thousands upon thousands of them, and together they form this vast, unseen circulatory system that keeps our world running smoothly.
But this vital system, it has a chronic disease. It's a slow-building problem that literally chokes the life out of these industrial hearts. And that problem is called fouling.
The absolute best way to picture fouling is to think of it like plaque building up in an artery. Over time, all these unwanted deposits, we're talking scale, rust, sludge, even microbial slime, they build up and coat the inside of the heat exchanger. This constricts the flow, and worse, it insulates the very surfaces that are supposed to be transferring heat. And the impact? It's immediate and it's severe. On the left, you've got a clean exchanger. It's the picture of efficiency. But on the right, that fouled exchanger is really struggling. The pressure drop skyrockets, which means the pumps have to work way harder, wasting just enormous amounts of energy. Heat transfer tanks, and the whole process can become unstable, even risking a complete plant shutdown. And this is not a simple problem. This plaque can be made of all sorts of different things. You've got your basic limescale and rust, sure, but you also have waxy hydrocarbon sludge and even living microbial slime. Each one of these needs a totally different approach to get rid of it safely. Now, for decades, the solution was, it was to blast these deposits away with really harsh, dangerous mineral acids. But that just created a whole new list of problems. Today, though, there's a much smarter, safer, and greener way to do this. And the difference is just night and day. The old way used these harsh acids that could literally eat away at the equipment itself. They could cause something called hydrogen embrittlement, which can make strong steel brittle and weak. It created dangerous fumes and a really nasty toxic waste problem. The new way, though, it uses advanced biodegradable chemistry. It poses zero risk to the equipment, it's safe for workers to be around, and the waste is easily neutralized. It is a total game changer. So here's the crucial idea. It's called deposit selective cleaning. This new chemistry is engineered to attack only the fouling, only the plaque, while it leaves the healthy metal and its protective layer totally untouched. It's like performing surgery with a laser instead of a sledgehammer. Now, this isn't just about using a better chemical. It's about a fundamentally smarter process from the very beginning to the very end. Let's take a look at how it actually works. It all starts with a deep engineering assessment. Experts analyze the exact type of fouling and the equipment's metallurgy. Then, almost like a pharmacist, they create a custom chemical recipe for that specific problem. That solution is then heated up and circulated through the exchanger in a closed loop, and they use advanced techniques like reversing the flow to knock loose any really stubborn deposits. And the chemical toolkit they use is incredibly sophisticated. It's not just one thing. You've got chelating agents that lock onto mineral scale, organic acids that gently dissolve rust, surfactants that act like a super-powered soap to break down oils, and then dispersants that keep all that dislodged gunk floating in the water so it gets flushed out cleanly. But the real power comes from combining this smart chemistry with physics. The solution is heated up to make the reactions happen faster, and it's circulated at an incredibly high flow rate. We're talking up to 60 cubic meters per hour. This creates a ton of turbulence that provides a powerful mechanical scrubbing action from the inside, getting into every last nook and cranny. Okay, so the science is smart, the process is safe, but does it actually work? Well, the results aren't just impressive, they are pretty transformative. Get this.
After a cleaning, some plants have seen up to a 45% improvement in heat transfer. That means the exchanger is working almost like it's brand new again, doing the exact job it was designed for with maximum efficiency.
And remember that clogged artery we talked about? Well, they've measured up to an 80% reduction in pressure drop. This means the pumps can finally breathe easy, using far, far less energy to move fluid through the system. The blockage is just gone.
And here's the real bottom line. The amount of energy wasted by a fouled exchanger is immense. After one of these smart chemical cleanings, that energy consumption just plummets. This translates directly into lower operating costs and a significantly smaller carbon footprint for the whole facility.
And this is a fully documented, engineered service. The client gets a complete report with all the before and after data, proof of waste disposal, and a full analysis. It ensures total transparency and really validates the results. It's a professional solution for a very complex industrial problem.
So, at the end of the day, this isn't just a story about cleaning pipes. It's about a bigger shift. A shift from brute force to intelligent, targeted solutions. It proves that we can make our most critical industries more efficient, safer, and cleaner, all at the same time. And that kind of leaves us with one final thought. If we can solve this hidden problem so elegantly, what other impossible industrial challenges are just waiting out there for a smarter approach?